A lot of what we look at, the reference point time zero, is often today, but it doesn't have to be. Sometimes I call it non-current, sometimes it's not today. So what the reference point time zero really is, it's the earliest time in the analysis. That's the time that you can set to time zero. And that could be today, doesn't have to be. In fact, the reference point sometimes could be in the future. Other times it can be in the past. It really just depends on the particular situation you're looking at. When is the earliest relevant point in time for the analysis, and that can be defined as time zero. So again, let's take a look at a couple of problems where time zero is not necessarily today. So we want to know what Yolanda's implied annual return is. 5 years ago, she invested $1,000, and 1 year ago, she had $1,200 in that account. So here we are today. For now, we'll call it today time zero. And 5 years ago, she had $1,000. 1 year ago, she had $1,200, and we want to know what's the rate that gets us that got her from $1,000 to $1,200. Well, let's retime it. So let's get into a time machine and go back 5 years. And so 5 years from now, the point at which that money was put into the account, we can call time zero. And we want to know how much she'll have 1 year from today, 1 year ago from today, which when we get out of our time machine here is 1, 2, 3, 4 years in the future. So what's the rate that'll take you from 1,000, or took her from 1,000 to 1,200 over 4 years? Put in 1,000. 4 years later, you have 1,200. 4 years later, you have 1,200. What is that rate? 4.66%. And alternatively, what you're really solving for is 1,000 times 1 plus r to the fourth is equal to 1,200. R is 4.66%. Here's another problem. In 6 years, Hans expects to sell his house for $500,000. So in 6 years, he expects $500,000. We want to know how much his house is expected to be worth in 2 years from today. What's the present value in 2 years? Discount rate's 8%. Well, if we said what's the value of the house today, it'd just be 500,000 divided by 1.08 to the sixth. But we're not asking for what the price of the house is today. It's what we expect it to be in 2 years. So what do? We get into our time machine, jump forward 2 years, and we get out and say, hey, look, this is when we want to know how much Hans' house is worth. And so what can we use to do that? We can look and say, hey, look, in 1, 2, 3, 4 years from when we get out of our time machine, which we get out of our time machine 2 years from today, and 4 years from when we get out is actually 6 years from today, but we get out and we look and say, hey, in 1, 2, 3, 4 years, this house is expected to be worth 500,000. We can sell it for 500,000. So it's just 500,000 divided by 1.08, to the 1, 2, 3, 4. That's what we expect the present value to be in 2 years. In 2 years from today. So in 2 years from today, we get out of our time machine, and 4 years later, we expect a cash flow of 500,000, discounted by 8%. Therefore, the value is expected to be 367,515 in 2 years. And again, notice that in here, kind of our PV, our earliest point in our analysis, is actually in the future, which is relatively common in the kinds of analysis that gets done in finance. In the previous example, the FV, which we're so used to having be at some point in the future, some point kind of later than today, but here it was actually 1 year ago. But it was the later point in our analysis. The earliest point was 5 years ago, and the later point was only 1 year ago, and so we had the time represented by PV and the time reflected by FV. Same thing here, even though it's in the future, it's the earliest point in time, and the later point in time is when they sell the house for 500,000.